What's up, guys? Here we go. This section, how do you solve and graph? There's the key thing. We're going to talk about solving and graphing in this particular video, but things called absolute value inequalities. So this is a continuation of section 7 here of chapter 1, and these are some examples of some absolute value, you see the symbols, with inequalities. What we just finished doing and mastering was absolute value equations that look like this. And remember, this is key. Here were your steps. We isolated if at all possible. And then we set up two equations. Remember that because you're going to see that in this video too. We took this thing and said, well, this distance here has to either be equal to 12, so 3x plus 5 is equal to 12, or the other situation is that this distance, 3x plus 5, is equal to negative 12. Those are your two possibilities. And then we solved this and got two answers for absolute value equations. So that was the steps there, and you're actually going to see with the steps for solving absolute value inequalities, it's really not much different, but we'll get to that. So these are what we're talking about in this video, and let's go back and recap what it means to be an absolute value. So here's absolute value again, and what the scoop is would be if I gave you like the absolute value of x was 4. Remember we said this before. It means I'm asking you what thing could you tell me has a distance that is exactly equal to 4 from 0 beep, on the number line. So if I'm standing on 0, I'm standing right here. The question is, if you walked 4 paces, if this was 4 miles and you had to walk 4 miles, you go 1, 2, 3, 4. So right there is one thing that would have a distance that's exactly equal to 4 from 0 on the number line. The other way you could walk is this. There's a distance of 1, there's 2, there's 3, there's 4. So there's why the absolute value of x equals 4 gives you two answers. X equals either negative 4 or x equals 4. Because you're looking for a distance here that is exactly 4. Well, that means it could be 4 or negative 4. But that comes into play big time when we start talking about these guys with absolute value inequalities. Because now what it's saying is, okay, I want something right here, right there, that you can tell me that is a distance from 0 on the number line that's bigger than 5. So again, if I'm standing right there on the number line at 0, I want to know how far would I have to walk to be a bigger distance, greater than 5 from 0 on the number line. Well, that means I have to walk 1 mile, 2 miles, 3 miles, 4 miles, 5 miles. I'd actually have to walk over the 5-mile mark and maybe get to 6. There's one that is a bigger distance than 5. Here's another one. 8 miles, 9 miles, 10 miles. If I just get crazy and run 11 miles, 13 miles, all that, 12, all that. So all of these here that's bigger than 5 but not including 5, all of these up here have a bigger distance, all of those, bigger distance than 5. But wait a minute. If I'm standing here again and I go the other way, here's 1 mile, here's 2 miles, here's 3 miles, here's 4 miles, here's 5. Now once I get to 6, I'm now a bigger distance from 0 on the number line than 5. I'm more than 5 miles away from my starting point right here on 0. There's a better way to say it. So negative 7 would work, negative 8 would work, negative 9, which basically means anywhere from here down, all of these down here, all of these, would all be bigger distances that I'd run, greater distances that I'd run than 5 miles from my starting point. But what I want you to look at is this. What does this graph look like? Open circles shaded to the right, open circles shaded to the left. You got it. That looks like this. It looks like an OR compound inequality. And by golly, it absolutely is. So here's the cool thing. Check this out. Anytime, I'm going to give you a huge hint. That is a greater than symbol. And anytime you see the word or the symbol greater than, I know I spelled it wrong, but I'm doing it for a purpose. That's a greater than symbol. Greater than means your graph, almost every single time that you have one of these, especially in class, it's going to look like this. But I can't say all the time because it's not true. But almost every time when you have a greater than, I'm going to tell you right now, it's going to look like an OR graph. Remember this picture? By the way, this is a picture of my grandfather sitting in a boat. Just kidding. I don't know who the guy is. But remember the ors we talked about with compounding inequalities. The graphs went boop, then went that way. So, back to this. It's a greater than, therefore greater, and by the way, this can go in that little section right there, where the little man's holding a little one hint. So greater than is always an or, it goes out. So now that we know that, what happens if we change it to something like this? Oh, baby! So now I'm looking at the absolute value of 7x plus 14 greater, there's another or, greater than or equal to 35. So you know the graph is going to go like this. It's going to be going out like that. In fact, you actually know this because it's equal to. You know there's going to be a closed dot there, a closed dot there. So what you have to find is that piece and that piece. That's it. So now here's your steps. As you notice, we're going to isolate the absolute value. And yes, this stuff right here needs to go in your notes along with all these examples I'm doing. But isolate the absolute value. It's already done. Most times it will be. Step number 2 looks very similar to absolute value equations. We're going to set up 2 inequalities. And here's how we're going to do it. Just like we did in this last one. I'll show you exactly how it works. So since we talked about the 2 scenarios, this guy right here, down here, is saying, well, I need my x value to be bigger than 5. And notice, all I did is just rewrote this bad boy because I want my distance to be bigger than 5. So that means I'm going to do the same thing here. I'm going to take this thing, which is my distance, this 7x plus 14. That's going to be one of my scenarios. I'm going to make it 7x plus 14 is greater than 35. So there's nothing different. It just stays exactly the same because I want that distance to be bigger than 35. But there's another situation, an or, which goes back to this one. The other side is down here. I want x to be less than negative 5. I want everything down here below negative 5 because that makes it more of a distance than 5. So there's my 2 scenarios in this one. Same exact thing applies with the bigger one. So I then take this 7x plus 14, and I say, well, this bad boy here needs to flip, so I want it to be less than or equal to, and this thing right here changes to now a negative 35, just like we did with this one. The symbol, notice, flipped, and I made it negative, and I made it negative. So it's the same exact thing with this one. So that is step number, as you see, boop, right here, number 2. And then we just got to solve those bad boys. So I'm going to pause this, you solve it, and then when I come back on, you'll see it's actually going to be solved, and then we'll finish up by graphing. So here you go. You see I subtracted 14, got negative 49. Subtracted 14 right here. Subtracted 14, subtracted 14. Gave me 21. Solve this up so I got x is greater than 3 or x is less than negative 7. So that means I'm going to put a closed circle on negative 7. Little part faces the letter, so therefore I'd shade this direction, like that. This one, I put a closed circle on 3. Little part is not facing the letter, its x is greater than, so I shade this way. And there, ladies and gentlemen, is my answer. So notice, I created 2 different equations. This one is bigger than 35, and then I got to flip the inequality and make it negative because I need something bigger than negative 35, but on the negative side, so that's why it's less than negative 35. So there's the situation with greater than. Let's now go to one where it says less than, and we'll see that scenario. So here's your 2 examples, less than, and your steps are still exactly the same, guys. There's nothing different. But here's the scoop. What I'm asking you and showing you here is that this distance, this thing that we put in for x, has to be less than 7. So if I'm standing right here at 0, I want to walk a distance that's less than 7. So if 7 is right here, I don't want to go any more than that. I want to go less than 7 distance-wise. So therefore, I could go here at 1, 2, 3, 4, 5, 6, and I could actually go to 7 and stop. That would still be okay. So anything in there would be fine. But the other scenario is I could actually then go and walk this way, but I don't want to go any more than negative 7 because if I go any more than negative 7, then my distance has become more than 7. I don't want that. I want it to be less than 7. So that means my distance then if I walk at negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, stop right there. I can't go any more than that. Why am I showing you this graph? Closed dot, shaded between. You got it. That one, ladies and gentlemen, looks like an and compound inequality. And it absolutely is. So here's your little hint. anytime you see a less than symbol, this is what you always say. Less than, no, it's not your computer, it's me repeating it. Less than. That right there, less than, can go over here with a little hint. So, this means in this scenario, I have two scenarios. I have two situations. It's either where this piece right here is x is less than 7, and the other situation is over here, it is x is greater than negative 7. So I'm going to use this example to show you how this one is set up. But notice the steps are still the same. Isolate, set up two equations. I'm going to draw this thing down through the middle. My first equation is going to look like this. I'm going to take the distance, 3x minus 9, just like I did here. I'm going to take the distance and make it x less than or equal to 7. Sorry, that's an equal to. So I'm going to make this one, 3x minus 9, is less than 6. I need that distance to be on the left side of 6. But the other situation is I need this distance, 3x minus 9, to be on the right side of negative 6, which means, oh boy, here we go. I must take this thing and flip it, greater than, just like I did here, greater than, I flipped it. But this also has to flip because I want the distance to be greater than negative 6. It's got to be between negative 6 and 6. So there's exactly my two equations. Now you guessed it. I come over here and I solve this bad boy, and then I'm going to graph it. So I'm going to pause this. I want you to solve it, and I want you to graph it, and it better be an and situation, so they better be going in. I'll pause it, you do it, and then replay, or not replay, just hit play, and you'll see if you're right or wrong. So there's your answers. I solved it, added 9, got 3, divided by 3, got that guy right there, which is x is greater than 1. That's this one right here. X is greater than 1, goes that way. And this guy here did the whole thing. X is less than 5. It would be this way right there. And I would add my answer. Sorry, I wouldn't add it. My final answer would just be what is in between. So all of these x values in between here would give you, when plugged in for x, an absolute value that has a distance that is less than 6. So there you go, guys. Listen, no checkpoint question for this video because of the length of it, but I'll tell you what, these are your steps. I hope and I pray that you put these things in your notes because you need to. Go back and watch this because there's a lot of great information in this, and rock and roll. I'm going to be pumped up in class to see you guys master these absolute value inequalities. It'll take practice, no doubt, but let's use these notes and practice, and we'll see you later.